Hi everyone, I continue with serial interfaces. A serial network has only two nodes, one at NH, and only transmits data between those 2 points. This makes managing a serial link much simpler than an Ethernet one, but the line connecting your router to the remote network has a far wider variety of options that can be set. Well, you can run a serial link between two routers by attaching the right cable between their serial ports. A serial line is usually provided by a phone company and runs between two different locations, much farther apart than the few hundred feet that Ethernet can tolerate. We concentrate on telecom provider TI circuits like the ones you would find in an ISP connection or between two offices. Here, the beginning of the show-in output of a typical Cisco TI interface, despite the scary reputation serial interface, have a serial line is in many ways much simpler to configure than an Ethernet interface because it has many fewer options. Okay. First, we see information about the hardware in this interface. Point 1. While nobody without a great deal of Cisco experience has any clue what a DSCC4 is, the integrated T1 CSU/DSU hints that this is a TI line. Okay, in the point 1, hardware is a type of hardware, and point 2 is encapsulation. Okay, hardware with integrate T1. Okay, and if you don't know what a CSU DSU is, see circuit design on page 45. Further down, we see the encapsulation field. The point 2, the encapsulation is the physical protocol spoken with the routers on both ends of the line. Just as we discussed earlier, the two common choices for TI lines are point-to-point protocol (TTP) and high-level data link control (HDLC). TTP, the protocol used in this example, is an old standard spoken by many different routers and modems, while HDLC is a Cisco-created protocol designed especially for high-bandwidth lines. While HDLC is more efficient than TTP, either works well for circuits of TI size or smaller. The important things to remember is that the router on both sides of the circuit must use the same physical protocol on a circuit. If one router claims that a circuit is speaking TTP while the other insists that it's HDLC, the line protocol will go down and stay down until the misconfiguration is fixed. The next point is configuring a serial interfaces. We cover serial interfaces in more detail in chapter 4, but here and now to get you started. The two basic things to configure on a serial interface here, the IP address and the encapsulation. For example, suppose we have a TA with an AP address, this AP address with this net mask and point-to-point protocol encapsulation. Go into configure mode for that interface and enter. Okay, AP address, net mask, encapsulation. Okay, modern Cisco routers set a variety of configuration by default, most of which disable functionality that is only used in advanced implementation. One setting that is worth changing through is the interface description, a field that can be a useful way to store important circuits-related information. Here we label our internet circuit as SOC to differentiate it from all other TI circuits. and we include the circuit ID that the telephone company used to identify this particular TI circuit. This way, if we should have found the telco and complained that a circuit is down, we have the necessary circuit ID right at hand. With the command description, ISP uplink and circuit ID. Okay. In the first step is configuring an IP address and net mask and the protocol to encapsulation. The next step is point a description with ISP provider. And other interfaces, Cisco supports a whole slew of different interfaces types. Okay, if you need one of these interfaces, the interface card or router will come with documentation describing how the interface is configured. Changes argue that the configuration process will closely resemble the one used for serial or Ethernet circuits, with minor changes for the connection protocol. Because these interfaces are comparatively rare among the people likely to read this book, we are not going to cover them in any detail. However, every router has two other sources of interface that we will address: loopback and null interfaces. Both are logical interfaces; they have no hardware associated with them but are created purely in software for the router to handle certain specialized tasks. In the first interface is loopback. Loopback interfaces are ones the local router uses to communicate with itself. They are useful because you can assign any IP address you like to them. For example, some advanced router configurations require the router have its own IP address without assigning that IP to any particular interface attached to the network. Loopback interface make this easy. You create loopback interface by configuration them. For example, to create an interface called loopback 0, you will go into configure mode and tell the router you are configuring that interface, then assign it an IP address as with any other interface. Okay, with enable mode, with conf terminal, with int loopback. Loopback 0. Okay, interface loopback 0 change state to up. Line protocol or interface loopback 0 change step up. Okay. And IP address. Okay. And the net mask. Sorry. Invalid input detected. Okay. Okay, and Control C. And show interfaces. Yeah. My first interface is Gigabit Ethernet. The second, okay, loopback. Okay, here is my new interface. Loopback is up, line protocol is up, connected, hardware is loopback, internet address. Okay, this is the address I assigned. Okay, well, And the next time you run show in the loopback interface you create appears in the list. A router now knows that the IP address is bound to this router but not to any particular interface. If someone attempts to ping that IP over any interface, the router will respond. To remove the loopback interface, go into configure mode and enter no and the interface name. Okay, again with conf terminal and no interface loop back 0. Interface loopback change state to administrative downline protocol on interface loopback 0 and control C in again show interface. And I delete the loopback interface. These interfaces are especially useful when combining two or more circuits into one large on-weight multi multi-link triple P and then using BGP. See Chapter 7. Over switch a link, you need to have a single IP address for a BGP peer, but when you share several circuits between you and your BGP peer, you need to have a consistent IP address for those peers to talk to. You should never create a loopback interface unless specially instructed to by your ISP or by Cisco Tech support. But on a similar note, you should know what they are so that they don't surprise you. And the null interface. The null interface is quite literally a router to nowhere. Traffic router to any null interface is simply discarded. With what you want to discard traffic, some IP address should never be seen on the public Ethernet, and you might wish to route those addresses to the bottomless void if packets are read from them. Null interfaces are most commonly used in BGP configuration, where you must have a static router for each block you wish to announce. We discussed BGP in more detail in Chapter 7. Only one null interface is required. Null 0 having multiple backhaulers in your router doesn't serve any purpose. The null interface doesn't need to be configured, you can simply route traffic to it. AP router, okay, IP, okay. Now that we have explored the basics of router interfaces, let's see how to use serial interface in the real world. Okay, this is all for this. See you in the next one.